Hello guys, welcome back to the channel again. Let's solve another challenge today from LeetCode. That's problem number 2683, neighboring bitwise XOR. So let's see what we are given. So zero indexed array derived with length n is derived by computing the bitwise XOR of adjacent values in the binary array original of length n. Specifically for each index I in the range 0 to n minus 1. If I is to n minus 1, it means like the last number, and derived I should be original I XOR to original 0, which means like it's a circular array, right? Otherwise, derived I is equal to the original I XOR original I plus 1. Given an array derived, our task is to determine whether there exists a valid binary array original that could have formed derived, right? So basically we are given the array derived. Now we have to determine if the original array that could lead to derived, that if that really exists, right? Then we need to return true if such array exists. Otherwise we need to return false. A binary array is an array containing only zeros and ones. So there is an example. We'll look at these examples in the whiteboard. Let's look at the constraints. So n is the length of a derived array, and n can range from 1 to 10 power 5. And the values in derived I are either zeros or ones. So this is a 10 power 5. So to solve this problem within 1 second, so it should be, we can now do this exponential, or we can now do this in the square algorithm. So we need to do this in linear algorithm. So let's look at these examples in the whiteboard. So before we look at the example, let's first recall what XOR is, right? XOR is basically if this is a binary numbers, right? If XOR is 0 and 1, it resolves to 1. If 1 XOR to 0 is also 1. If it's 1 to 1 is 0. If it's 0, 0, also 0, right? If we just look at the example, this 1, 1 leads to 0, 0, 0 also leads 0, 1, 0, 0, 1 leads 1, 1, 0 also leads 1, 0, 0 leads to 0. Basically, to make this 1, there's two basically numbers, they should be different, either 0 or 1, or 1 or 0, it leads to 1, otherwise it leads to 0, right? So let's see in example 1. So we are given this derived 1, 1, 0. We need to determine if the original array exists. Let's see. So how we can derive this derived array, right? By basically, let's change the color. By basically, we need to do the XOR between the zeros element and the first element, 0 and 1. So it gives to 1. So we can really derive the first element. And 1 and 0, these two guys, the second element and the third element, if we do XOR 1 and 0 according to this, so it should give to 1, right? And to get the last element, if it's the last element, that the last element should be XORed with the first element. If we do XOR 0 to 0 according to this, it is 0, right? So then we need to return true. So we can really derive that the derived array, right? And the second one, let's say we are given the 0, 0. We need to determine if that original array really exists. So let's test if that exists, right? So we can do the 0 to 1 XOR 0 to 1. According to this, it is 1, so we can get the first element. Or then the last element to the first element XOR, then we can also get this one, right? 0 to 1, 1 to 0, it's also given. So we need to return true. So let's do the third example. Let's say we are given the 0, 1. An original array the length is n, okay? An original array can have only n element. N element, and also each element can be either 0 or 1. There are only 4 combinations, right? 0, 1, 1, 0, 1, 1, or 0, 1, right? How we obtain the first element in the derived array? 0 and 1 XOR, okay? That gives 1, right? And to get the second element in the derived array, we need to do this XOR to the first element, right? 1 XOR to 0, it should be 1, right? It's not 0, right? This array is not valid. And the second one, 1 to 0, we can get this one, 0 to 1. Again, it results to 1. So it should be returning 0, but it's returning 1. So this is not valid, right? 1 to 1. 1 to 1, if we do XOR 1 to 1 is 0. Again, like this one to this one is also 0. This array really returns 0, 0. So this is not valid. 0, 0, this is not valid. So at the very end, we need to return this false, right? Basically, we are given the derived array. We need to determine if the original array that we can derive the derived array, right? So let's remember another property of XOR operation. It's called a commutative, right? If we are given to A XOR B XOR C, we can change the place. A XOR C XOR B. It's also equal to C XOR B XOR A, right? So this is valid. And according to this, if two of them are equal, so it's going to lead to 0. If they are different, then it's going to lead to 1, right? According to this, A to A is equal to B to B is equal to C to C, and all equal to 0, right? Now, how we can really determine if the original array exists without really computing that array? Okay, imagine we are given this original array A, B, and C. And how we derived the derived array? Derived array, we did the first element of derived array is A XOR B, right? And the second element of the derived array is B XOR C. And last element in the derived array is C XOR to B, right? So what can you note here? So basically A to B, B to C, C to A, right? So we know this property. We know this commutative property. We know the A to A is 0, B to B is 0, C to C 0. So let's see what we can do, right? Why can't we simply get the XOR all of this? If we do the XOR all of this, A, right, B, this XOR, let's change the color, and B, C, XOR, C, A, XOR, right? And use this commutative property. If we use the commutative property, we can collect all of the A's together, right? A, XOR, B, XOR, C, right? According to this, if they are same, then this should be leading to 0. If it's same, this should be leading to 0, and this is also 0. So this is actually 0, right? So if the original array exists, and if we just take all of the XOR of all the elements of the derived array, in that case, if it's 0, then we return true. If it does not lead to 0, then we return false. Let's check this array. So derived array is 1, 1, 0. Let's take the XOR. 1, XOR, 1, XOR, and the last element 0. 1 to 1 is what? It's 0, right? But the XOR of 1 to 1 is 0, so it's basically 0. And the second element, it's 1 to 1, right? Two elements of the derived, right? That's also 0. Look at the third example. 1 XOR 0. Is that 0? No, it's 1. So it's not 0. So that's why we return false. So I hope this walkthrough is clear. So all we need to do is just iterate that derived array and get the XOR of all of the elements, right? And we test at the end. If it's equal to 0, then we return true. Otherwise, we return false. So let's look at the code. Okay, this is very short code. So initially, we're going to initialize the result to 0. Then we are going to iterate for the element in derived array. Then we just compute the result, right? The result is equal to result. We're going to do the XOR of the element, right? Then at the very end, we expect that this result should be returning 0, right? Because if the XOR of all the elements in the derived array, if it's 0, then this should return true, right? If the result is 0, right? If the result is 0, then it will return true. If the result is not 0, then it will return false, right? The time and space complexity of this, we are just iterating through the derived array just once. It's O of n, and the space complexity is O of 1, right? We are not storing anything, only result, right? It's just a 0 or a single number. So basically, time complexity is O of n, and space complexity is O of 1. Okay, yeah, that's it for this problem. Yeah, I hope this explanation is clear. If you like this explanation and the solution, right, please subscribe and share and comment the video. Okay, thank you. See you in the next video.